Welcome back, guys. Alright, so in this video we're going to be showing the proof for dy over dx giving us this from this. Right, we know in our pre-calculus and calculus class that if we are given any function, deriving it, we're going to use this formula, but we're going to be showing the proof using binomial expansion. But before then, let's try and solve using first principle. Let's derive this question using first principle. Right, let's try and derive this function and see how the answer collates with this using our steps. If we can use our steps and understand the steps, how we're able to get the answer for this, applying that steps to this one, we're good to go. Right, so I said that in deriving this using first principle, I gave you guys 4 steps, right? I said let this be our equation 1, let y equal to 2x squared plus 6x minus 4 be our equation 1, right? Then in forming our equation 2, we replace y with what? Y plus delta y, the change in it, and we replace x with what? X plus delta x, that's the change. That's what we're going to use to form our equation 2 using this. So this is our equation 1. Our equation 2 will now change this using what? Y plus delta y equal to 2. There's an x here giving us what? X plus dx, right? All squared plus 6 plus 6x plus dx minus 4, right? This becomes our equation 2. That's the first step. So let's call this our step 1, right? Step 1 is that we form 2 equations, one carrying the mean, and then the second equation is that we're replacing y with delta y, and anywhere we see x, we replace x with delta x, right? That being the step 1. What becomes our step 2 and step 3? In step 2, we subtract equation 2 from 1, right? Equation 2 from 1. That's what happens in step 2. So in doing that, our equation 2 for this part of the session becomes what? Y plus delta y, that's the equation 2 minus y, equal to this one minus the up one. So let's put a square bracket. We have 2 bracket x plus delta x all square, right? Plus what? Plus 6 bracket x plus delta x, and then what? Minus 4. This is the first one. This is our equation 2. Subtracting it from this, that is minus, let's just put this as bracket, what? 2x squared, right? Plus 6x minus 4, right? So that's equation 2 minus equation 1. That's everything here, subtracting everything here. And doing that, remember we have plus y minus y, we cancel out. We'll be left with what? With delta y, which is equal to what? Let's expand this bracket. First, expanding this bracket, we have 2 bracket what? I taught you how to expand brackets, right? We'll square this. We're going to have x squared, right? 2 times x times dx. We have plus 2 times x times dx, right? And then plus we square this separately. That's delta x squared, right? That's expanding this. In expanding this, on this we have plus 6 times x gives us what? 6x. 6 times delta x, we have 6 delta x minus 4, right? And then gives us the minus of this one, 2x squared, and then what? Plus 6x minus 4. That's for this. That's basically for this. And then what do? We use this 2 to open this bracket. That gives us that our delta y is 2x squared. 2 times 2, that's 4x delta x plus what? 2 times this, we have 2 delta x squared plus what? Plus 6x minus 6 delta x minus 4. We use the minus to open the bracket. We have minus 2x squared minus 6x plus 4. Minus times minus gives us plus. So what do? We cancel out. I told you that everything that is here, we cancel out with everything that is here, that represents itself here. Look at this now. This is plus 2x, right? Look at it. It is minus 2x here. So they will cancel. Plus 2x minus 2x squared. They will cancel out. What else? This is 6 minus 6s. You see that there is a plus 6s here to cancel out, right? And then this is minus 4. Look at this, a plus 4 here to cancel out. So you see now, we'll calculate what we're left with. Our leftover for change in y is what? 4x delta x plus what? 2 delta x all squared plus what? 6 delta x That's what we're left with, right? Our step three is to what? Divide both sides by what? By change in x. What that means is that our change in y will be over change in x equal to 4x change in x over change in x plus what? Plus 2 change in x squared over what? Change in x plus what? 6 change in x over change in x. Again, cancelling. So from here, change in x will take out change in x. Change in x will take 1 from here, and then change in x will take out change in x. Left to the left, right? Our leftover is change in y over change in x is equal to what? 4x plus what? Plus 2 change in x plus 6. And then step 3 is to apply limits, right? Or step 4, final step is to apply limits, right? So step 4 is that we apply the limit condition that we reduce change in y to 0 for what? For the y, that's change in y over change in x, which will be equal to what? The y over dx. So our dy over dx will be equal to the limit of what? Of delta x to 0 of what? Of change in y over change in x. What that simply means is that this condition shows that wherever we see delta x in this function, we turn it to 0. So if you look at this now, this is the function now. It's going to be 4x plus what? 2 change in x. Now we're reducing change in x to 0 and it's here, so it becomes 0, right? And then plus 6, so it means that this is gone. What that means is that our dy over dx, totally our dy over dx from what we just did is what? Is 4x plus 6. It's 4x plus 6. That's by differentiation. Now this is the long method, right? If we apply a shorter method, we are still going to get the same answer. That's the proof we're trying to do now. That is by saying if you want to apply a shorter method, like I've taught you, that if y is this,